Unit 5, Relationships in Triangles. We're on Lesson 5.3, Medians and Altitudes in Triangles. Objectives. Identify special segments in triangles and understand theorems about them. We're going to be reviewing, once we get these last two, the 4 special segments in triangles that we've been dealing with, and you need to be able to recognize them and know their properties. Find and use the point of concurrency of the medians of the triangle and solve problems, improve relationships in triangles, and find the point of concurrency of the altitudes of a triangle. Lesson 3, Part 2, Altitudes in Triangles, Orthocenter. What is an altitude? An altitude is a segment joining a vertex to the opposite side so that it's perpendicular to that side. Altitudes can mean inside, outside, or on a triangle. Inside when it's acute, outside when it's obtuse, and on when it's a right triangle. Orthocenter. The 3 altitudes of a triangle intersect at a point called the orthocenter. We're going to use the diagram up above to answer the following questions. We're going to list the altitudes. First one is segment AE. You can see it's perpendicular to the opposite side BC. Segment BF, it's perpendicular to the opposite side AC. And segment CD, perpendicular to the opposite side of angle C, segment BA, and the orthocenter is point P. Summing it up, review of the centers of a triangle. Something is the intersection of the 3 medians. The medians would be the centroid. Another one is the intersection of the 3 angle bisectors. The angle bisectors all meet at the end center. Intersection of the 3 altitudes is going to be orthocenter. That's what we just went over. The intersection of the 3 perpendicular bisectors is circumcenter. The point that's equidistant from the vertices is also the circumcenter, and equidistant from the sides of a triangle would be made by the angle bisectors, and that's the end center. Now, looking on the diagrams and based on the markings, classify each center as circumcenter, end center, centroid, or orthocenter. So number 1, that looks like angle bisectors, and they're going to meet at the end center. 2, they look like altitudes. That's going to be orthocenter. 3, it's going from a vertex to the midpoint of the opposite side. That's medians, so it meets at the centroid. Number 4, those look like perpendicular bisectors, so that's circumcenter. 5, those are not special segments, but that's a relationship. That point is equidistant to the vertices, so that's going to be the circumcenter. Next one is just medians again, so centroid. This one, careful, it has perpendiculars like number 4 does and number 2, but it's different because now from that point of intersection, it's the same distance, it's equidistant to the sides of the triangle. That happens with the end center and angle bisectors. And 8, orthocenter, those are altitudes again. The 3 somethings of the sides of a triangle intersect at the circumcenter. That's going to be perpendicular bisectors. The 3 somethings of the angles of a triangle intersect at the end center. That's angle bisectors. The 3 something meets at the centroid, so that would be the medians. The 3 what meets at the orthocenter, that's going to be altitude. A blank is equidistant from the vertices of the triangle, that's circumcenter, and equidistant from the sides, that's the end center. Identify the special segment, segment AB. Looks like it's going through the midpoint of a side and perpendicular, so that's a perpendicular bisector. This one looks definitely like an angle bisector. This is a segment, it goes through a vertex perpendicular to the other side, doesn't go through a midpoint or anything. That's an altitude. And this one goes from point B, a vertex, to the midpoint of the opposite side. So that's a median. Special segments in triangles. Number 5. If the measure of angle CAD, that angle right there, equals measure of angle EAD, that's looking like an angle bisector to me. That is going to be B. What is the altitude for triangle ACE? So there's triangle ACE. Altitude needs to go from a vertex perpendicular to the opposite side. And in this case, it's perpendicular to the extension of the opposite side because there's no way you can do a segment A or from point A to segment CE, so that is perpendicular. So you have to extend the side. So segment AB is going to be the altitude. That is now the end of part 2, altitudes in triangles, orthocenters.